In the current theaters of conflict, traumatic events such as IED detonations and vehicle rollovers are creating invisible injuries to the warfighter as a result of high G acceleration and overpressure to the body and internal organs. The correlation to these events and the long-term effects are not well known. Several independent sensor projects have begun the effort to collect data from both the soldier and the vehicle perspective, but to fully characterize the event, an integrated system of systems approach is needed to gather event data for both mounted and dismounted operations. The system operation must be as transparent as possible to the soldier, be easily integrated onto any tactical vehicle, and the system architecture must allow for easy incorporation of new sensor technologies. Recognizing these needs, and with direction from Army leadership, the Army's Rapid Equipping Force coordinated with several stakeholders from the medical, soldier, vehicle, test, and acquisition communities to create the Integrated Blast Effect Sensor Suite, or IBESS program. The IBESS team has developed a system based on COTS, GOTS, and commercially available data processing architectures, reducing development time and risk, and creating a robust system which allows for future growth and technology insertion. This approach employs non-proprietary, standards-based interfaces and software which is completely government-owned. IBESS is composed of two major subsystems, the soldier system and the vehicle system. These two subsystems communicate with each other over wireless links to form an integrated system of systems. IBESS gathers soldier-focused event data for both mounted and dismounted scenarios. A soldier in a mounted operation is wirelessly associated to a specific seat location via the soldier's body unit and vehicle system. If the vehicle encounters a traumatic event, dynamic event recorders mounted rigidly on the vehicle hull measure, record, and locally store time-tagged shock data from the event. As soon as the hull-mounted event recorders detect the event recorders are triggered to capture and locally store time-tagged seat acceleration data. As the event's impact starts to affect the soldier system wakes up, captures and locally stores the time-tagged data from its sensors. Finally, soldier data is wirelessly transferred to the vehicle, where it is centrally stored, along with the recorded seat, soldier location, and vehicle hull data in the ATEC Black Box Data Recorder, allowing a holistic picture of the event on the soldier and the vehicle to be captured. In a dismounted scenario, the soldier system will wake up out of its power-saving mode in response to an overpressure or shock event exceeding predefined thresholds, and capture data through the Heads 2 helmet sensor system if installed, and the newly developed soldier body unit with its mix of shock and pressure sensors. As before, if the soldier enters a vehicle, the SBU will wirelessly associate with the vehicle through the seat and initiate transfer of recorded soldier system data. The overall system of systems is focused on data completeness through the mix and placement of sensors, data redundancy by local and central storage of data, and data coherence with time-tagged and cumulative data that captures the soldier's experience of dynamic events both in and out of the vehicle. Choosing commercial standards and existing technology components has allowed the IBESS team to make rapid progress. From initial discussion in April 2011 and contract award in July 2011, the team quickly developed and demonstrated working prototypes of all of the system components and interfaces, allowing a fit and functional test on 4 vehicle types to be performed in December 2011. Kits for a battalion of soldiers and associated MRAP vehicles will begin delivery and deployment in April of 2012. The Rapid Equipping Force, along with the Army medical community, is also developing the post-event database and analysis tools that will make maximum use of this valuable data to characterize these traumatic events and understand their medical implications. The IBESS program brought together a team to rapidly develop a soldier-centric system of systems, which provides time-sync data from multiple locations and sensors in and out of a vehicle. It is an open, robust, government-owned design, allowing for future growth and providing redundancy and reliability to aid in the development of effective medical diagnosis and treatment of the warfighter.